In this question, we've been told that there's a box of mass 16 kilograms on a plane inclined at an angle of theta to the horizontal. We're told that tan theta is 4/3. This will be useful later on. The box is pulled up the plane by a rope whose tension is T newtons, and it acts in the direction of the greatest slope, causing an acceleration of 0.25 meters per second squared. The box is also experiencing friction at a magnitude of a half R newtons down the plane. R, as always, is going to be the normal reaction between the box and the plane. We're tasked to model the box as a particle so that we can find the value of R and T. Okay, so let's just start. As always, I would like to produce my own diagram that I can label and annotate however I like. So, firstly, I'm going to want to draw the box larger, just so I can fit all my labeling around it. We know that it has a mass of 16 kilograms, so it has a weight of 16 G. I know that it's going to be useful to think about these components, so I'll start to depict them from now. There's going to be a reaction force. We know that there's a driving force, which is called T at the moment, and we know there's going to be some friction acting down the plane. It's a half R. We're labeled up. I'm going to add in these components: 16G cosine theta and 16G sine theta. My diagram's complete and ready to use. We were also told that tan theta equaled 4/3. So I'm going to quickly use a right angle triangle, some Pythagoras, and some trigonometry to state sine theta and cosine theta. Now, this particular triangle is a 3-4-5 triangle, and I would hope you would recognize this rather than actually having to do the Pythagoras. The 3-4-5, the 6-8-10, anything that's a Pythagorean triple, we should be able to just know instantly as and when we see it. Okay, now that I have these, they'll be useful when I'm trying to substitute after resolving. So let's start by resolving perpendicular to the slope. The direction of movement first is going to be up the slope. So as we're resolving, we know which values are positive and which are negative. So resolving perpendicular, where there's only two forces to consider, R is going to equal 16G cosine theta. Cosine theta is 3/5. 16G times 3/5. That gets us 9.6 G. This is good enough for an answer, but if you want it in terms of newtons, it will be 94.1 newtons. And you see I've rounded to 3 significant figures. Resolving in the direction of motion, resolving parallel to the plane, we're using Newton's second law. So F equals ma, and we'll go for all the positive forces. It's only the tension that's positive. Subtract a half R for the friction, subtract 16G sine theta for the parallel component of weight. That is going to be multiplied by 16 for the mass times 0.25 for the acceleration. Okay, so all of this can be tidied up. We can substitute in sine theta, we can substitute in R, and some of these values we can do in our heads before we reach for our calculator, but our value for tension, our value for T, is going to be 4 plus 17.6 G. In terms of newtons, to 3 significant figures, that's 176 newtons.